And hello, we're back with math again today. We're going to continue with the distributive property, and we're going to talk about how the distributive property can help us with our factors of 3. If you think of a 3 as just a 2 and a 1, that's your 3. You can figure out your 2 factors, multiply something times 2, use the identity property, multiply it times 1 more, and then put that together. So, Bob, take it away.
How can you break apart arrays to multiply with 3? Think about this question during the lesson. The Park District has canoes stored in 3 rows. There are 6 canoes in each row. What is the total number of canoes stored? How does an array help you multiply? An array puts items into equal rows and columns so that it is easier to find the total number. What operation will you choose to find the total when you have an array? You can multiply to find the total for an array. Find 3 times 6. Use 1's facts and 2's facts to help you multiply with 3. Make an array for each multiplication sentence. Look at the way 3 times 6 was broken apart to help you multiply. Why is it okay to break apart the array? You can break apart the array because the number of items does not change. How is breaking apart the array helpful? You can use arrays for facts you already know to help find the total. 1 times 6 equals 6. 2 times 6 equals 12. 12 plus 6 equals 18. 3 times 6 is 3 rows of 6. That is 2 6's plus 1 more 6. 2 6's are 12. 1 6 is 6. 12 plus 6 equals 18. 3 times 6 equals 18. There are 18 canoes. Now you know how to break apart an array to help you multiply.
Okay, so here we are in our book on page 116. Using arrays to help you solve some of these harder. Now, 3 is not really a hard factor. A lot of you can count by 3's, and you use the same idea. If we wanted to do 5, no, let's not do 5. 6 times 3. You can hold up 6 fingers and count by 3's, and maybe you're able to do that. But this idea of distributive property and breaking apart larger arrays into smaller numbers will be really helpful as we get into higher factors. So we start with this, and we have the total number of canoes. And again, as they mentioned, it doesn't matter how we break this, we still have the same number of canoes. Now, you can only break it one way. You either break it across this way or break it up and down. You can't really do both. So here, instead of having 3, we would have 2 rows of 6 and 1 more row of 6. And 2 groups of 6 would be 6 plus 6. 1 group of 6 would be another 6, and we're going to get 18 pretty easily. All right, let's jump over here to the convince me. Suppose there were 7 canoes in each row. How can 2 groups of 7 equals 14 help you find the total number of canoes? Well, if we added 1 more canoe, I wouldn't float in those. Those are not very stable looking canoes. Now we would have, and they broke it apart to tell us we have 2 groups of 7 and then 1 more group of 7. So if we know 2 groups of 7 is 14, we just have to add 1 more group of 7, because 1 times 7 is 7. That's a plus. 14 plus 1 more group of 7 would give us 21. Let's look at the guided practice. Do you understand? Do you understand? Selena arranged plants in 3 rows in her garden. She put 6 plants in each row. How many plants did she arrange? So she has 3 rows or 3 groups of 6. And we can think of that. I'm going to break it apart just to kind of think about it. I'm going to take this 3 and break it into a 2 and a 1. So it'd be 2 groups of 6 plus that one more group of 6. 2 groups of 6 is 12, plus one more group of 6 is 6. So all together it equals 18. Alicia has 3 vases and she wants 9 flowers in each vase. She buys enough flowers for 2 vases. For the 3rd vase, she cuts 9 flowers from her garden. How can Alicia use 2 times 9 equals 18 to find out how many flowers she needs? So, she has 3 rows of 9 already. Or she has 3 vases with 9 in each one is what she wants. She already has 2. So all she has to do is figure out what is one more vase with 9 in it. How much is that going to be? And of course anything times 9 is 9. So if she knows how much she has in the 2 vases, she's only got to figure out how much for one more vase. Let's look at this one. You may use counters or pictures. You can use your fingers, whatever helps you out. 3 groups of 10. Anything times 10, you take the other factor and throw a 0 on the end. 30. 3 groups of 6. Well, that's the same as 2 groups of 6 plus one more group of 6. Plus, it's what this whole page was about. So we know that one is 18. 3 groups of 8. Well, that's 2 groups of 8, which is 16, plus one more group of 8, 24. 3 groups of 2, you can flip those and say, well, that's the same as 2 groups of 3, or you can use your fingers, 2, 4, 6. 3 groups of 7, we did that here, and we got 21. And 3 groups of 3, maybe you can count by 3s. 3, 6, 9. So, here you're going to use the distributive property because they showed you that. If you need to use your fingers, use your fingers. If you can count by multiples, count by multiples. Use the tools you have. Use the brain you have to help you to solve these. Multiplying times 3.